Hey everyone, this is the first video of an entire series focusing on introduction to programming that covers topics from programming fundamentals to data structures and algorithms. So without any further ado, let's get started. So first of all, let's talk about what is programming. In simple terms, attempting to get a computer to complete a specific task without making mistakes. In other words, we can say it is a way through which we communicate with the computer to accomplish a certain task. We do that by giving the computer a set of instructions to be executed in order to achieve the goal of completing the task. So, with that being said, let's move on to the types of programming languages, or more specifically, types of programming languages based on the way in which we communicate with computers. Computers can only understand binary code, that is, zeros and ones, which is also known as machine code. But humans can't understand machine code. Therefore, programming languages are used as a medium to communicate with computers. Now, let's talk about the types of languages in detail. First, we have assembly languages. It is any low level language in which there is a strong relationship between the instructions of the language and the machine code instructions. For example, the instruction move A, B means save the content of B into A register. So what are registers? Registers are small storage locations in the central processing unit which are used for faster access while performing various operations. Now the assembly code is ready. Now this assembly code is to be converted into machine understandable code. So the assembly code is converted into executable machine code by a program referred to as an assembler. It was becoming very difficult to work with assembly code because it was long and tedious to write. It was very difficult to find bugs and fairly difficult to maintain the code too. Also, assembly code written for one architecture was not portable to another. So they were CPU architecture dependent. Hence, high-level programming languages were invented. High-level programming languages are easier to use and they also make the process of developing a program far simpler and more understandable than when using a low-level language. Some of the popular high-level programming languages are Java, C++, Python, JavaScript, etc. Now let's talk about the types of programming languages based on the way in which they are designed. So first we have procedural languages. It is the programming model based upon the concept of calling procedures. Procedures are also known as routines or functions, simply consist of a series of computational instructions to be carried out. During a program's execution, any given procedure might be called at any given point. Some examples include Fortran, COBOL, C, etc. Next up, we have functional programming languages. These languages use an approach to problem solving that treats every computation as a mathematical function. Some examples include JavaScript, Python, Scala, etc. The third and final type of programming languages are called object-oriented programming languages. Object-oriented programming is a programming paradigm based on the concept of objects. Objects are real-world entities that have state and behavior. States are called attributes or data members. Behaviors are called as methods or member functions. We will look into detail on object-oriented programming in a separate video. So some examples of object-oriented programming languages include Python, C++, Java, JavaScript, PHP, etc. As you might have noticed, one language could fall into multiple categories. For example, Python is procedural, functional, and object-oriented, and JavaScript is functional and object-oriented. Therefore, it's not necessary that one language must belong to a single category. So with that being said, let us move on to a much more important topic, which is memory management. So memory management is done using stack and heap memory. So first of all, let's talk about stack memory. The allocation happens on contiguous blocks of memory. The size of the memory to be allocated is known to the compiler, and whenever a function is called, its variables get memory allocated on the stack. And whenever the function call is over, the memory for the variables is deallocated. We will see in detail about functions in a separate video. For now, Consider it to be a block of statements that perform a task. So now that stack memory is clear, let's move on to talk about heap memory. Memory is allocated during execution of instructions written by programmers. This is called heap because it is a pile of memory space available for allocation and deallocation. Whenever we create an object, it always gets space allocated in heap memory, and the referencing information to these objects are stored in stack memory. Now, what does that mean? Let us look at this in detail with an example. So consider the example shown here. So irrespective of the programming language, consider we have two variables, s and str. So s is a variable that stores a string of characters. Here we have hello. And str is another variable which has a copy of s. That is, the content of s is also there in str. So it is a copy of s. So also you can see that we have stack and heap memories shown in the diagram on the left hand side and right hand side respectively. So you can see that we have str and s on the stack. So the memory address of value hello, that is 5000, is stored in these locations. And the actual value, which is hello, is at the address location 5000 in the heap. So these two variables, str and s, are reference variables which refer to this particular address location 5000, which contains the value hello. Let us move on to the key differences between stack and heap memory. In a stack, the allocation and deallocation are automatically done by the compiler, whereas in heap, it needs to be done by the programmer manually. Processing of heap memory is quite slow as compared to stack memory. Now that is very evident from the next point, that is, stack memory has less storage as compared to heap memory. Therefore, the processing is also quite fast in stack memory as compared to heap memory. So with that being said, let's move on to the final topic of today's session, which is garbage collection. So it is a form of automatic memory management. It relieves the programmer from performing manual memory management, where the programmer specifies what objects to deallocate and return to the memory system and when to do so. In C or C++, programmer is responsible for both creation and destruction of objects. Sometimes programmer neglects destruction of useless objects. So what happens as a result of that? So when new objects are created, sufficient memory may not be available and the entire program will terminate abnormally, causing out of memory errors. But in Java, garbage collector takes care of these things. We will learn more about that in the upcoming videos. Now that we have understood the fundamentals of programming and languages, we will deep dive further into other concepts in the upcoming videos. So with this, let's wrap up today's session. As always, thank you so much for watching this video. Please like and share this video, and also don't forget to subscribe to the channel and hit the notification bell so that you will get notified each time I upload a new video. With that being said, I'll see you in the next one.